Hi guys, welcome to our video lecture series of Laplace transforms. So we are working on the inverse transforms and we have talked about some properties of Laplace inverse transforms in the previous videos. So we talked about the Laplace inverse transform of a function when it is multiplied by s. So the inverse transform of this function is given by d over dt function of t, that is we get it from f of s plus the function at 0 multiplied by delta t. So this is the property when s is multiplied by f of s, and the second property we learned is when f of s is divided by s, and it is very simple. It's integral 0 to t, and the Laplace inverse transform of f of s, the dt, or we can write it as 0 to t function of t dt. This function of t we can get by applying the inverse transform of the function of s. So the third property we learned was the first shifting property. First shifting property. So first shifting property is very useful in solving the inverse transform. So the first shifting property says that if the Laplace inverse of f of s plus a, so we can write it as e raised to the power negative a t multiplied by the Laplace inverse of f of s. So this is the general idea we talked in the previous lecture. So today we will continue the second shifting property. So the second shifting property says that Laplace inverse of e raised to the power negative as f of s is equals to the function of t minus a multiplied by the unity step function of t minus a. So basically this property deals with the unity step functions, and we will take some examples so we will understand in a good manner. So let's say that we have an example e raised to the power negative pi of s divided by s plus 3. So first of all we have to break this problem in this form. So we can see that if we want to find the Laplace inverse of this function e raised to the power negative pi s over s plus 3, so I can see that a is equals to pi. A is equals to pi, and the function of s here is 1 over s plus 3. So now we can write it as e raised to the power negative pi e raised to the power negative pi s multiplied by 1 over s plus 3, and the Laplace inverse we need to find here, that is equals to the function of t minus a. So the function of t minus a we can get from this function, this 1 over s plus 3. That implies that we have, first of all we have to find the Laplace inverse of 1 over s plus 3. That will be equal to e raised to the power negative 3t. So see, this is the function of t, and I can convert it into function of t minus a, because a is equals to pi, and the function of t we get is e raised to the power negative 3t. So the function of t minus a will be equals to e raised to the power negative 3 times t minus pi. So this is f of t minus a, and the f of t minus a multiplied by u of t minus a will be simply equals to e raised to the power negative 3 into t minus pi multiplied by the unity step of t minus pi. So we get to the answer, and the Laplace inverse transform of e raised to the power negative pi s over s plus 3 is simply equals to e raised to the power negative 3 multiplied by t minus pi multiplied by unit step of t minus pi. So this is our answer, and now we'll take another example for good understanding. So the second example is Laplace inverse of e raised to the power negative s over s plus 1 whole cubed. So the first thing we need to do is identify f of s. So in this case our f of s is 1 over s plus 1 whole cubed. So if I want to find the inverse transform of 1 over s plus 1 whole cubed, so I can find it by using some properties of Laplace transforms we learned in the previous lecture. So it is e raised to the power negative t multiplied by t squared over 2 factorial. So this is our function of t. This is function of t, and if I want to find the function of t minus a, so in this case a is simply 1, because here it is 1 e raised to the power negative 1s. So so a is equals to 1, so I can write it as e raised to the power negative t uh, minus 1 dot t minus 1 whole squared over 2 factorial. So this is the function of t minus a. This is the function of t minus a. Now I can write it as function of t minus a multiplied by unit step of t minus a. That will be equals to e raised to the power negative t minus 1 multiplied by t minus 1 whole squared divided by 2 factorial, and it's multiplied by unit step of t minus 1. So that is our final answer, and this example is very clear to you. I hope you have understood a lot of this property. So in next lecture we will talk more about the property. Thank you guys, thank you.